Welcome back. In this lesson, we're going to talk about weathering. And weathering, I guess, comes from the word weather. If water and rain and wind beat against a rock, it is possible over a long period of time that that rock can be eaten away. And it happens by different ways. That you could have something in that water. There could be acid in that water that actually reacts with that rock and it dissolves that rock, like a chemical reaction. It could break apart by roots of plants or ice. Ice can split a rock very wide open. Once that happens, that little piece of rock can then be taken away by water or wind and then used later to construct new rocks. New sedimentary rocks can come from these particles made up by weathering. So we have weathering where it all breaks apart. Erosion, later we're going to see where it's transported away, and then it can contribute back to the rock cycle. So let's look at some examples. Okay, so weathering is when the rocks are broken down into smaller pieces. So it can be to where you just have a chunk that's broken off of a mountain, or it could be where a particle is actually dissolved into some water. So for instance, rain falls on the side of a building and some of the very outside molecules will actually dissolve into that water and then run off the building. And so it's a little bit smaller than it was. It is possible that you can have some acid in that rain, and the acid could actually have a reaction with the stone and then dissolve some of that. The first one we're going to look at is mechanical weathering, and this is also called physical weathering. And this is where it's not being dissolved, it's just being broken down into smaller pieces. And there's a number of ways that this can happen. The main way around here would be that water gets in the crack of a rock, a crack that maybe weathering had caused before, and now there's a crack in that rock and now it gets wet. When the temperature drops below freezing, that water turns into ice. And ice is, you all know that ice floats. Well, the reason why it floats is because it's less dense, because it takes up more space. It's the same amount of stuff, but it takes up more space. So there's a density, less density. Well, that means it takes up more space. It's going to expand. Ice always expands. So if water were to get in the rock and it would freeze, this is called frost wedging. And frost wedging is when as the water gets into the rock and expands, it's creating a force on that rock that could split that rock. It could split it into tiny little pieces. Little tiny sand would fall off the mountain, or huge boulders if enough water could break it. Okay, so either case, it's going to be the same it'll be the same stuff at the end. So mechanical weathering is not going to change anything. It's not going to be a chemical reaction. It's just breaking it apart into something smaller. You could have other ways that this could happen. For instance, a tree root could do it. As a tree is growing down, that root could actually go down into the rock and eventually split the rock. On the left is some igneous rock that is exfoliating, where it's actually shearing off in sheets. What's happening is that mountain, there's forces on that mountain making it want to go up, and there's nothing above it to force it down. This used to be the inside of a volcano, and there used to be ground on top of it. That ground is all eroded away, and because the ground was pushing at the same force that was being pushed up, it used to be fine, nothing moved, but now that ground is gone, that force is acting up. Well, that's a solid rock, one solid rock that's being forced out, and so it splits. So there's some other ways. Frost wedging is the main way that happens. Chemical weathering is when you actually have something dissolved. So in the case of seawater or rainwater that possibly will have some acid rain mixed with it, or even just regular rainwater, it is very possible that tiny bits of that rock little at a time, can dissolve. You've seen it in the river. You've seen little dips in the river. There's dips in this example. All that's been worn away by water that has actually dissolved some of that outside of the rock. Now, if it is hotter, it is possible that more chemical would happen. A chemical reaction will happen faster. So in the case of something dissolving, hot water will dissolve rocks more than cold water will. So the temperature of the water could affect that. Also, oxygen can react with rocks. A lot of times oxidation will make the rock a different color. It might, like a tarnish, if you've ever seen tarnish on silver or tarnish on brass. Rocks can tarnish the same way. It's called oxidation, where the air is actually reacting with it. And over time, it could possibly eat away also at that rock. Carbon dioxide can do it because carbon dioxide reacts with rain to make acid. Okay, so when pure water plus a little bit of carbon dioxide mixing with that water can create carbonic acid, which is a weak acid but can react with limestone. So in the case of these caves that you see, these caverns, that's limestone rock. It used to be solid rock. Well, a crack along the top, water got in there, that water had acid in it, and then that acid ate away the rock slowly, and then there must be a stream or something in that that was able to take away the material and then leave a void. So that is called carbonic acid reacting with limestone. And so acid precipitation, whether it's snow, acid rain, acid sleet, is essentially pollutants in the air, carbon dioxide, sulfurs, other things that can create acids. Then that acid gets in the water. The rain then can react with stone. Okay, so the rates. Normally this happens very, very slowly, and we are also already mentioned that temperature does have a lot to do with it. The warmer the climate, the more a chemical reaction occurs. Physical, I would say, would happen more where you're going to get frost wedging. So wherever it drops below freezing so that water can break apart and cause potholes on the ground, that would probably be more physical weathering. Now, the idea of surface area is important because anything that's going to react will react on the outside. Let's say it's chemical weathering. That chemical will react on the outside. So as a rock is smaller and smaller, it's more and more likely for it to be dissolved. Imagine dissolving a grain of sugar or a sugar cube. A grain of sugar would dissolve faster because it's dissolving on the outside, and since it's so small, it's able to simply dissolve completely. A huge block would have to be dissolving at the outside for a long time. Okay, the Earth's topography, what the lay of the land, could determine whether something is going to weather or erode more. Something steep. If you have weathering on a steep mountain and then gravity pulls it away, that exposes the new rocks so that it could then be weathered. So the lay of the land, whether it's flat or steep, does have a lot to do with whether or not that particular part of the rocks are weathered. So the bank of a river is more likely to be eroded than, say, even the bottom of the river, even though it's being ground by the water. Water sloshing onto the sides can erode very, very easily.